Hi everyone. Good morning, good afternoon, and good evening to all are joining us globally. Hope you all are doing good. I am Partharu, UN Program Manager for the Microsoft Reactor India, and I welcome you all to our MVP Connect along with Kunal. I'd like to bring in Kunal. Hey, hi Kunal, how are you doing? Kunal, you on mute?
Hello, Parth. I am doing good. Thank you so much. What about you?
I am all good, Kunal. So, what do we have today?
So today we are going to understand how to create robust and high available applications in Microsoft Azure using various services offered by Azure. So, and we are going to use PaaS services, so like Azure Front Door. So Azure Front Door is our main focus today, and we'll see how to use Front Door to get solid um, resilience application that we are going to create today.
Okay, looks like an exciting session today. So, Kunal,
Yeah,
before we begin, and the audience, everyone, so we'll go through our code of conduct.
sure.
Please take a moment to read our code of conduct. We are all here to learn together. So, please be respectful of other people's views, understanding of differences, being kind, and considerate in the way you all engage. And yes, obviously, we do encourage you all to participate. Please drop all your questions in the chat section, and we'll take the questions from there. So, Kunal, the floor is all yours to begin the session.
Thank you so much. Thank you so much, Parth. So, hello, friends. Uh, I'm going to share my screen now. I hope it is visible to you all.
Yes, Kunal, it is visible. Can you bring up the slide? Yes.
Yeah,
Okay.
it's visible, right?
Yes, yes, yes.
Okay, fantastic, friends. So our today's session is how to achieve high availability on Azure PaaS for web application. Let us take a look on the agenda. What I'm going to cover today. So we are going to start with various types of load balancers. What is the concept here, friends? Say you want to create a robust, resilient infrastructure for your services. And for that, you cannot rely on a single instance of the service or the provision on the cloud. You must have multiple
Hey,
instances of your services running over there.
hey, Kunal. Sorry to drop in there. Uh,
Yes,
can we come out of the presenter view from the presentation
yes.
because we see it in a very small size.
Is it fine now?
Yeah, yeah.
Okay. So here we are going to understand load balances because as we want to create a robust, solid architecture of our web applications or for our services hosted on the Azure, we cannot rely on the single instance because if you rely on the single instance, if something goes wrong, your service will be down. So generally what we do, we can have multiple instances, and based on the scenarios, based on your application requirement, these instances could be in the single data center or in the same availability zone, or it should be across different regions. But if you are running with multiple instances, to redirect your traffic, you need to understand load balancers. And here we have various types of load balancers are there. It is always critical to understand what load balancer we should use, when we should use it, and how to pick a perfect load balancer for your solution. Then we are going to focus on Azure Front Door. We'll understand what is Azure Front Door, how Azure Front Door works. And when we talk about the Azure Front Door working mechanism, we should understand this Anycast and split TCP. It is very powerful, very important things to understand over here. Because of these two, Azure Front Door is heavily used today. Then we are going to understand various features of Azure Front Door, and then we'll see the demo. Now, if I talk about various types of load balancers here, So we know that in Azure we have four types of load balancers are there, or here we can say we have four types for load balancer is available. First one is a general load balancers, then we have application gateway, we have traffic manager, and we have Azure Front Door. We are going to understand why we have these four types of load balancers and how to pick a particular load balancer over here. So when you talk about the load balancer and four types of load balancers, first of all, this load balancing service is divided into two parts. One is global and one is regional. So yes, you can divide these four load balancers under two categories, global and regional, and also HTTP and non-HTTP. Sorry, excuse me. So here you can see we have these four load balancers. Out of these four load balancers, if I go for this general load balancer, this is working only at the regional level. So this works at the regional level. Then we have application gateway. Application gateway works on global level. Traffic manager also works at global level. And front door also works at global level. So this is general categories over here. Again, few load balancers are working with HTTP protocol and few are not supporting HTTP protocol. So for example, if you are working with this general load balancer, it works with TCP UDP. Here you are not going to have any SSL offloading. We are not going to have URL based routing. So once a request reach to your particular network, inside particular subnetwork, now to distribute this request across multiple VMs, you go for these load balancers over there. When you work with application gateway, traffic manager, and Azure Front Door. So again, traffic manager is working with only DNS. It is a DNS based traffic distribution. So it's like DNS caching, and for any request, time to leave is very important. So this is DNS based one. Then we have this application gateway and Azure Front Door. Again, if I remove it, it is my mistake. It is also regional. So application gateway and Azure Front Door, both are almost same. This is working with regional services. This is working with global. But in regional, it offers you all of those things. So here, this is going to offer you HTTPS is going to work with HTTP or HTTPS, SSL offloading, URL based routing, session affinity or cookie based affinity, and same thing is provided by Azure Front Door. Apart from these, Azure Front Door is working globally. That means if any region is down, it has no effect. And also Azure Front Door is having routing methods, so which we generally take from traffic manager. So you can say application gateway plus traffic manager, because traffic manager is global, application gateway is regional, but it supports all these HTTPS based routing, SSL offloading, all those things are provided by Front Door. And from traffic manager, it takes globality and routing methods. So application gateway plus traffic manager are equals to Azure Front Door over here. So these three, again, you can understand this is layer 4 service, while these three are working at layer 7. So this is layer 7 based services. So all the layer 7 based capabilities you would get here when you are working with application gateway, traffic manager, or Azure Front Door. Now, next thing, we'll go here. We'll see actually what is Azure Front Door, how we can use it, and what we can do with Azure Front Door. So as we mentioned, Azure Front Door is a service which comes under Application Delivery Network. It's a service which comes under Application Delivery Network over here, right? Okay. It is developed by Microsoft, and in today's world, almost all the microservices which are designed by DevOps team in Microsoft, they all are transfer over Azure Front Door. Even Bing is using Azure Front Door. Office 365 is using Azure Front Door. It is very powerful. It is very, very powerful application delivery network over here. Next, we have to understand how it works. So to understand how it works, I'm going to draw one more diagram here, friends. So here, take a look how Azure Front Door works. So first of all, say for Azure Front Door, when we are working with Azure Front Door, we have our backends, which are also known as origins. So this is my origins here. Suppose I have one web application, or say one instance of the web application is hosted on East US. Second instance of the same web application is hosted on the West US. And third instance of this web application is hosted on premises. So I have one end user here. So here two things comes to the mind, that if I want to give faster response to the request of my end user, and if he is in East US, I have to give him East US endpoint. If he travels to West US, he has to use this West US endpoint. And if we are creating high available architecture, so these two instances will work. These two instances will work as a failover mechanism. So if West US is down, again he has to use East US endpoint. So this is not the practical way. So that time we need one global load balancer, which acts like application delivery network. And as user is here in the East US, he will get the response from the East US. And I want even further make sure that this request is response is going very fast. So for that, I want my site acceleration. So I want dynamic site acceleration. So requests should go faster, and user should have high performance, low latency. So for that, what we are going to do, how it works here. So first of all, say Microsoft has one global network available. Say all the data centers are here in the Microsoft global network. So this is my Microsoft global network. Now, for each and for this network, we have various edges. They are also known as point of presence, POP. Probably these edges are used. These edges are used for CDN, like it is used as a content delivery network, right? And the same edges. So these edges are there in the various locations. It is there in almost all the cities, right? All over the world. So these edges are used like, say, content delivery network, and same ADs are used to deliver these Azure Front Door profiles. So this is, as I mentioned here, this is my POP, point of presence, or AGs, which are used to deliver front door along with other content. Now what happens here? This mechanism, when your user is going to send a request, when user is going to send a request, this request would be handled by any of these POP based on the location, or you can say it would be served from the POP which is nearest to the user location. So that means your service is, this is the service IP, public IP address, for example, because we can also work with private IP. So this public IP of the services are available for each and every location. Here you have Azure Front Door profile, and all Azure Front Door locations are aware of your service public IP. So when your user send a request, it would be responded, it would be served from any of these POP, and this is known as anycast. This is known as anycast because each and every POP is available. POP is having your public IP. This is known as anycast. Now, second thing to understand is split TCP. So generally, when we work with TCP protocol, say this is my user again, and user is going to send a request. Suppose user is going to send request to West US region. So what happens? This is your request here. So first of all, we establish TCP connection. Then we have TLS. Then there would be request and response. So there is total time it takes to establish a TCP connection from user to your backend here. But when we work with Azure Front Door, so what happens here? So for Azure Front Door now, if I have this user available, so again I'm going to have one more document here and say this is what my East US, this is my West US, this is my on-prem website. Here these all are my point of present. So they are POP, also known as AGs for front door. Now what happens? Suppose a user send a request. So TCP connection will be established from user location to your POP. So this is your TCP connection. This is your TLS connection. And then only request will go to your backend. So here you are saving the time for TCP and TLS. And also once we get the response, we get the response in form of chunk. And we can implement caching here. So even we can further implement, we get improvement in the performance. So anycast, that means it will be served from the nearest location. Second thing is this split TCP. So now your TCP connection acknowledgement is TLS is established from your location to this point of present only. It's not going to from your location to your backend. So this is how we get improvement here. Now, along with these two things, so Anycast, split TCP, then we can implement caching, we can have SSL offloading as we mentioned, we can have compression for the data. So whatever data we are getting, that we can compress, so we get further performance improvement over there. So these all are the various features of Azure Front Door. So first of all, as you mentioned, it is a global application delivery network working on layer 7. You get all the features of application gateway plus traffic manager. Application gateway is regional. This is global. And it supports HTTP, HTTPS over here. When we work with front door, we get two flavors. Or say we have two products over there. One is front door standard. And one is front door premium. Even when you go for front door premium, that time you can have private endpoint. You go to the docs.microsoft.com, you will see all the locations of the POP, the point of presence for Azure Front Door, which makes your application very powerful. It is a global, so no need to worry about the regional downtime. Now suppose I have one application, I have one customer, and what I want to do is I want to create high available infrastructure. So here I have two virtual machines. This is my, say, West Europe region, and this is my East US region. Here I have VM1 and VM2. Same way here I have VM1 and VM2. Now what I want here is I want path-based routing here. URL path-based routing. So for that, generally what we can do, it is like I can use application gateway. So here I have application gateway. Same way here I have application gateway. If request is coming from video, it will go to this region. If request is coming for image, it will go to this VM. Same way, if request is coming for video, it will come to this VM. For image, it will come to this VM. But now here, when I make a request, probably say from, you can say West US or the Central US. So that time request should be redirected to this region here. And if I make a request from somewhere around Middle East, it should go to this West Europe region. So for that, here we use front door. I can use traffic manager, friends, but traffic manager works with only DNS. It's a DNS based routing. Plus it is not having that SSL offloading and all. And I want to work with HTTP or HTTPS. So that's why here we go for front door. So now what happens here? We have this high available application architecture. What happens here? What happens here? So application gateway generally we use for web servers. Right? So these two are my web servers here, and these two are also my web servers. So now when request is coming from Central US, it will be redirected to this application gateway, and based on the path in the request, either it will be redirected to video or image. And if request is coming from the Middle East, it would be either would be redirected to here in the West Europe, and again depending on the path, Either he would be redirected to this VM or this VM. Now suppose this VM is down. So that time user would be redirected to this VM here. This is our failover mechanism. And by default, front door supports it, right? So user will be redirected to this location. Same way, if this one is down, he will be redirected to this location. So for that purpose, Azure Front Door keep on checking the status of all the machines in the backend pool. It checks the health probe. So here we can use front door for high available infrastructure. Even it works with low latency, so performance wise it is very fast. So we are going to, and also we can implement front door with web application firewall also. So we can use front door like firewall also. So now we are going to see some demo here. So first of all, the same architecture demo what I have designed here, I am going to show you. So what I have 4 VMs, 2 VM in Europe region, 2 VMs in the East US region. For both the VMs, I have my IIS role installed because they are the web servers. So let us check here. Let me take RDP here. And here you can see I have this IIS installed, and this is the public IP address of this VM. So let me somewhere open public IP address of the VM. Also, let me log into Azure portal here. I go to resource groups, and I have one resource group for West Europe, the West Europe resource group, and here I have this VM, West Europe video VM. I take the public IP address of this VM here. And here I have video folder, and I have one page default.htm. You can see this is the West Europe video VM. Now I have one more VM here, so I go to the Azure portal again, and in the resource group I see another VM. This is West Europe image VM. I have this public IP address here, and I can tag image default.html. This is a West Europe image VM. So as of now, what I did, as we discussed here, I have in the West Europe region, I have these 2 VM ready. One is for video, one is for image. That's what I show you. Now I have one more resource group here, and here I have RG East US region, and here also I am going to have this video VM. Let me copy the public IP address. Let me have this one. I can say video. The East US video VM, and from here only, let me copy the public IP address of image VM. So here you can see I have this four. This is the West Europe video VM, West Europe image VM, East US image VM, East US video VM. So again here I have these two VMs are also running. This is my East US, East US. Now here I'm going to have two application gateway. So I have two application gateway available with me. So it would be available for both the region, right? So like again, if I go to the Azure portal and I here in the East US only, you can see I go to this East US region. Here, this is my application gateway. I have created application gateway. And even if I take the public address of this application gateway here, this is what URL based routing I'm going to show you. Now here, I'm just going to put video slash default.html. You can see it is taking me to the East US. It's the same IP. So this is the IP of application gateway. And here, if I put image, you can see it is taking me to the East US image, the same URL. So this is what URL based routing we have established using application gateway for East US region. So here, this is what application gateway we did. Now same thing, if I want to check, if I go to resource group and if I go to this West Europe, and here I have this application gateway. See, I mean, it's not possible to do all the steps here because for VM creation, installation of IIS, configuration of application gateway takes a lot of time, and we don't have that time. So our focus is on the architecture theory part and how we design this front door. So that I'm going to create for you. Then here I copy the same part, and here if I put video and default.html. So this is taking me to the West Europe, and here if I do image, it is taking me to the West Europe image. To understand, I will take this one. Just for your understanding, I take this one, I mention here, and I take this one, and I mention here. Now, say the IP, okay, so let me go here. So now what happens for this West Europe, you have one public IP address of the application gateway. So in this case, that public IP address is, this is the public IP address. And same way for East Europe application gateway, we have this public IP address that is this one. So now these are the public IP address of my application gateway. And these I'm going to connect to Azure Front Door. So now we are going to create one Azure Front Door, and we are going to connect this public IP address of the application gateway. Now we know Front Door is deployed by multiple point of presence, or you can say in other words, all the point of presence will have this public IP address. So now from wherever location you will access this URL, you will get the response from the nearest point of present, that is Anycast. And again, to get you the request response situation, they will split the TCP. So your TCP request, TCP connection would be from your location to point of present. Your TLS would be from your location to point of present. This is your nearest location. And then point of present to your backend service would be connected. And then you get the request response over there. As we discussed, we can cache it, we can compress the output. Output would be in form of chunk, right? So now we are going to create Azure Front Door. So now I will create here Azure Front Door. So in the Azure portal, I'm going to find out, say, Front Door CDN and profile. Also, one thing to understand, if you go to load balancers here, and here you can see in the load balancers tab, you get all the 4 load balancers like application gateway, front door, CDN, load balancer, and traffic manager. So we discussed what is application gateway, load balancer, traffic manager, what's the difference over there. And now here we have this front door CDN profile. I have one front door CDN running. I'm going to create one more front door here. Now here we have multiple options, like I can go for quick create, or I'll go for other offerings. And from here, I'm going to select Azure Front Door Classic. I'm going to click on continue. And these I can put in any another resource group. It has nothing to do with resource group of your resources, like of your services, like West US or West Europe or East US. If you want to put it, you can put it to the same resource group. But I'm going to create a new resource group here, say RG Microsoft Reactor Front Door. And these I'm going to put in the Southeast Asia. Next, here we have 3 things to configure. One is this front end or domain. So even you can have your custom domains with the front door, but you cannot have custom domains with the application gateway, right? You cannot have SSL certificate with application gateway, but here we have these custom domains. Now here we are going to create our front ends of the domains, and we are going to create the backend pools, and then we are going to write the routing rules. So I'm going to click on this plus, and I have to provide some host name. It would be your unique name, and that would have this azurefd.net as a suffix over there. So I'm going to put, say, MS Reactor Front Door endpoint. And as we discussed, I can have session affinity. I can also use front door with web application firewall. When we talk about the session affinity, means, say, first your request will go to the particular server. They know the session of the server, and all the subsequent requests from your machine will go to the particular machine only, particular server only. Then it will not go to, it will not implement that latency and all those stuff over there. So here, I'm just going to select, I'm just going to provide this host name. I'm just going to click on add. Now so it's very simple. Now here we have to add this backend pool. So I'm going to click on backend pool, and here I'm going to provide a name. So say in my case, I'm going to provide a name, for example, say my pool. And here I'm going to add a backend. I'm going to add backend. Now what would be my backend here? It would be, the backend would be your application gateway here. So I'm just going to click on add backend, and here you can see I get various services what are supported by front door. This is backend host type. So here we have app service or cloud service. If I want, I can simply have 2 app service, and that I can connect with my front door application. I can implement global distribution. But I want to show you the more robust architecture. So we have front door, then we have application gateway, then we have our apps, virtual machines over there. But here we can have app service, cloud service, storage, application gateway, the classic storage, API management, public IP address, traffic manager, or custom host. I'm going to select application gateway. I have my subscription here, and now here you can see I get both of my application gateway. So this is my East US application gateway. Priority, this is again like your routing methods, and we have various routing methods available over here. Priority 1 means always this is having highest priority. Request will go to this one and wait. So how many, if you are having multiple requests, I mean thousands of requests are going on over there, right? So you can see 1,000 requests will go to this one, 500 requests will go to another one. And I'm just going to click on add. Same way, I'm going to add one more backend pool, say application gateway. This time it would be West Europe. Same thing, one, and I just want to give 1,000, and I'm just going to go ahead. So this is two things are added over here. There's all the things are the same, like health probes. So like every 30 seconds it's going to check the status of your backend pool machines. They are working fine, then it's okay. If they're unhealthy, the front door will discard them, right? And the load balancing sample sizes, successful requires, sample requires. That is how internally they check whether the load balancing is in effect or not. I'm just going to click on add. And now finally I have to define the routing rules. I just click on here and I'm going to create the routing rule here. So for the routing rule, okay, one thing we have to see, one more thing. Let me go to my pool. And I want to work with HTTP because we are not having HTTPS, we have HTTP here. And here in the routing rule now, say simple name I just provide, say this is rule 1. Accepted protocol, I'm just going to select HTTP only. Front end, this is what my front door endpoint, what you have defined. All the things are the same. Backend pool is my pool. And here also I'm going to put match request. So whatever request will come, it will match with this HTTP request over there. I'm just going to click on add. This is done. And now I'm just going to click on next, tags, review plus create. And create. It will take around 2 to 3 minutes. So as we discussed, the front door is...
Hey Kunal, we have few questions in our chat. Would you like to take up?
Yes, please.
So there is a question from Ankush Sharma.
Okay.
His question is like how data replicates in this case from West Europe to East US. In this case, for a failover scenario.
See, this failover scenario is implemented automatically. So once this service is ready, I will show that I'm going to stop my one of the VM and the request would be automatically redirected to another region. That's the one thing. Now for data applications, like these are the two instances over there, right? So let me go here. First of all, my diagrams, what you define. So now suppose you want to replicate the data. So suppose now so these are front end. Again, these are the backends over there. Then always you have to implement that backup and disaster recovery over there, right? Also, like you have to take backup of your VM frequently, that you can implement using the VM backup situations, and the site recovery you can also create over there. So that is the totally different things how you implement backup. Front door has nothing to do with this. Say once how you these two VMs you are going to synchronize, because these are the two instances, that could be two databases also, right? So for that we have that database backup, VM backup, all those things are available over here. We are just going to understand how the failover mechanism works and how the traffic is redirected over there. That is the part of Azure Front Door that it does automatically. Parth, before we take another question, let me just show this thing. So probably many of the doubts would be clear. So like
Sure.
In this case, my front door resource is ready. And here you can see I have this front end host. And now I take this one here. And now here I put video. It takes few minutes because just recently deployed, right? It will take few seconds. So we just need to wait over here, and we'll see. Let me check for email. Okay, I get the point because it works with HTTP only in our case. So I'm just going to remove HTTPS. So here you can see it is taking me to the West Europe because I am here in India. So instead of East US, it is taking me to the West Europe. Even if I go for image here, I need to remove this HTTPS. It's taking me to the West Europe. It is not taking me to East US. So now what happens here? If you see here, I am sending a request to front door, but it is always taking me to the West Europe. Either it's taking me to this video based on my path-based routing, or it's taking me to the image. It is hitting this application gateway that is doing further redirection over there. It is not taking me to the East US. So this is, first of all, this is working because of any cast. Because even in the West Europe, there is a point of present available, which is aware of my front door application endpoint and my backend endpoints over there. So that's why when I make a request, it will see the nearest location, right, to reduce the latency. That is because of any cast, it is going there. Even if you see that, even I can show you here, we have something. Let me just show you. We have Azure speed test. If I go here as your speed test, and now here, just see, I'm going to select two regions. One is what we have West Europe, and here we have East US. So here it will show me. See, West Europe is 187 ms, while East US is 260. I mean, it's almost more than West Europe. So from my region, the lowest latency is West Europe, Netherlands somewhere. And that's why all the requests are by default going to West US. Now, let me do one thing. Here I come to this West US video VM, and I'm going to stop it. When I stop it, just wait for a few seconds, and then we'll see. So now West Europe region is West US, resource is down, and we have this high available infrastructure running. Your application will go to now East US. Here I create the virtual machine, and inside that virtual machine I have IIS role, right? I'm checking one HTML page. You can have your web applications, you can have anything over there, right? So it is stopped probably. Yes, it is stopped. So now if I go back to this one, and now let me check it for video. Now it should go to East US. Is redirecting, just it takes 2-3 seconds. Let us see. I think even the VM is still, yeah, now it's down. Then it would be, you will be redirected to that East US. We'll see. Meanwhile, yes. But here, okay, it will take me to that East US. We just need to wait here. If I do image here, it will work. Yeah, see, now it's taking me to the East US, right? It will take me to East US. Even I just need to refresh here. See, because my West US is down. So this is what high available infrastructure we create. Initially, because of any caste, it takes the nearest POP and serve you the resource, right? The same POPs are used for Azure CDN also. Even you can see the locations of those POPs over there. And when my one particular region was down, so it was redirected to the another one. So this is what we did. Say this one was down, so it's redirected to this one. And because initially it was taking me West, even say if I check for image, it will always take me to West Europe because this is the nearest location for me. But if I do video, it will take me to East US because the nearest location is down, right? So that is what here we implement high available infrastructure with Azure Front Door. We know that we have multiple load balancers. The general load balancer is TCP UDP based load balancer, which works with layer 4, which is the regional one. Then we have application gateway. It works on layer 7. It is also regional one, but it supports HTTP, HTTPS. All the layer 7 capabilities would be there. But it doesn't support custom domain. And it's not, you are not having, it will not support custom domain over there, correct. And then we have traffic manager. It is a global one, but it is DNS based routing. And then finally here we have front door. It is global one, layer 7. Implement all the things of traffic manager, all the various routing methods. We have web application firewall concept over here. Plus it implements all the features of application gateway, like cookie based affinity, SSL offloading, URL path based routing, supports HTTP, HTTPS over there, right? It is available for all the POPs of the Microsoft Global Network for on all the edges. It internally uses split TCP to improve the performance. And we have not covered here, but for all the responses, we can compress the response. We can have caching for the responses. We can have session-based, cookie-based affinity. All those things are also possible over there, right? So thank you so much. If you have any questions, we can go for the questions now. Yes, Parth? Any other questions are there? We can take up the questions. Janil, the same thing is there. If you go to this front door, and in the front door, I select, I have this, let me show you. Let me share the screen again. So here you can see, if I go to this front door service, what we have designed so far, the reactor front door. And here if I go to front door designer, then here I have these backend pools. In the backend pools, when I try to add backend, and you know, one front door can support multiple sites here. That is what you can say, I can have one more backend. And here if I do go to add backend, then here I can use any app services, right? I have to just provide that app services, whatever available over there with you. You can say one app service is available in this location. I can even configure them. So front door supports multiple sites also. I can also go for any public IP. So if your Kubernetes cluster over there or Azure container instance is over there, you can provide these public IPs over there. Even it supports custom hosts also. That is also possible, right?
Hey, Janil, I hope that answers your question. Any more questions? Please drop all your questions in a chat section. Final call to ask the questions. I'm also sharing your Reactor LinkedIn group where you can join us on LinkedIn. So, Kunal, I think let's call for a wrap then. I don't
Sure.
see any questions coming in. Thank you everyone. Thank you so much for having us today. And thank you, Kunal, for making this
Thank you so
possible.
much.
A great learning to all the audience. Kunal, I'll also like to share the audience our learn module link where they can take the learning further.
Yes.
Yes. So here is the learn module link where you can take your learning further. Please feel free to reach Kunal on LinkedIn for any doubts.
Sure. Sure.
So there is one more question. Okay. Can you see the question? The custom domain is not possible using front door.
No,
The
I
solution.
told custom domain is possible using front door. Custom domain is not possible using application gateway.
Okay.
So front door supports custom domain. The application gateway was not supporting custom domain. So that time we have to take care of like our third party domain providers like GoDaddy or whatever domain providers are there, right? Even they do not support SSL offloading. So these were the limitation of the application gateway, but front door supports custom domain.
I hope that answers your question. And please do reach out to Kunal. I'm posting his Twitter ID. Yeah. Okay, Kunal. Thank you. Thank you, everyone. Enjoy the rest of your day.
Thank you. Thank you so much.